Assalamualaikum guys. So now we go to the new chapter which is interpolation. So many times we are dealing with discrete point, any points, okay? So for example, when you're conducting the experiment, you obtain the data and there are many points, right? So for example, in this diagram, okay, we have the point, for example, 1, 1, and then 2, 3, and then 3, 2, and 5, 7. And if you notice here, okay, x is from 1 to 5. This is what we call as domain of fx. And let's say you want to know what is the value of y when x equals to 4. Okay, as you notice that 4 is within the domain, right? So we are able to know, okay, the y when x equals to 4, okay, by using this interpolation. Okay, in other words, interpolation is estimating an unknown value between known values. Okay, I take another example. Let's say you want to know what is y when x equals to 7. Okay, as you notice here, x in between, okay, 1 to 5, and 7 is outside of this domain. Okay, therefore we cannot use interpolation if x is outside the domain. We need to use extrapolation. Okay, however, in this course we only cover on interpolation. Okay, in order to find the value of y or unknown value, we need to find, okay, the function that connect all these points. Okay, so how we can set up the function that can connect all these points? Therefore, in order to connect all these points, we use the polynomial function. So this polynomial function is also known as interpolation function that passes all the points. It must pass all the points. Okay, so just to recap, what is the polynomial function? Function, okay, that power of x is non-negative integer. Okay, we have, for example, for first order polynomial, okay, also known as linear function or equation. For example, we have y equals to 5x plus 7. So you can see here, x is power of 1. This one will also known as first order polynomial. Okay, and then we have the second order, which is known as a quadratic equation. Okay, for example, y equals to 4x squared plus 3x plus 1. This one, the polynomial with order 2. And also we have till the nth order. So why we use the polynomial? Because it is easy to evaluate the unknown using this polynomial function as compared to the other function. For example, trigo and ln. Okay, this polynomial function much more straightforward. Okay, and there are a few methods, okay, to find the polynomial function or interpolation function. The first one, what we call as Newton divided difference method. The second one is Lagrange interpolation method. And the third one is spline. Okay, so we will go one by one. We will start with Newton's divided difference polynomial method. Okay, now we go to the first method to find the interpolation function and to interpolate the unknown value using Newton's divided difference polynomial. Okay, so we go to first interpolation, which is linear interpolation. So when we talk about the linear interpolation, it means that this one is the first order, okay, polynomial function. So you have to take note, yeah, for first order you need at least, okay, 2 points to get the interpolation function. For the second order, you need at least 3 points, okay. For third order, you need at least 4 points, and for the nth order you need n plus 1 points. Okay, so for this linear interpolation, at least 2 points needed. Okay, now we go to example 1. Using linear interpolation, estimate ln 2. Okay, I want you to take note that this ln 2 is actually the actual function, okay, or function that are provided to you. Okay, actual function that later you need to compare. Okay, what actually this question asks you is to find, okay, what is the fx or y. Sometimes we use fx, sometimes we use y, give the same meaning. Okay, when x equals 2. Okay, so how do I know when x equal to 2? I look here. Okay, just to recap, if I have ln 2 equals to some value, okay, the whole ln 2 here is known as, okay, the fx, and x is this one, 2 here. Let's say I have sine 3 equals to 0.0523. Okay, therefore, okay, the fx is, or y is, okay, 0.0523 or sine 3. Okay, while x equals to 3. So this is how you interpret the given function here. So for a here, okay, we start with a. Okay, we have 2 points. Okay, first, when x equal to 1, y 0, and another point when x equal to 6 and y 1.791759. Later you need to estimate, after you interpolate the function, you need to estimate what is the value of y when x equals to 2. Okay, I will show you one by one. Okay, now we go to step number 1 to identify points. As I mentioned before, for linear function, at least 2 points needed, right? So we have 2 points here. So x1, okay, y1, where we have, okay, 1 0, and then x2, y2, we have 6 and 1.791759. Okay, so step number 2, okay, find slope. You need to find the slope and intercept. Okay, so you know that this is the linear equation, so we can use the straight line equation, y equals to mx plus c. Okay, before that you need to find the slope lah. Slope is given by m equals to change in y over change in x. So we have y2 minus y1 over x2 minus x1. So we have here 1.791759, okay, minus 0 over 6 minus 1. So the slope that you will get is 0.358. Okay, so now after you find the slope, okay, you can get what is the intercept using the straight line equation, y equals to mx plus c. Okay, intercept is given by the c, right? So you have the slope here. So what is y and x? You can substitute, okay, either this first point or the second point. Okay, it's up to you. You will get the same answer. So I just take this first point here. I put 0 equals to m is 0.358. Okay, and then 1 plus c. Therefore, c equals to negative 0.358. Okay, and then now after you find slope and intercept, you can set up, okay, step number 3, set up the first order polynomial equation or the linear equation. Okay, so when you set up, okay, just substitute back what is m and what is c. So y equals to mx plus c. Okay, therefore, okay, y equals to 0.358 x minus 0.358. Easy, right? And step number 4, after you obtain the first order polynomial function, okay, what you can do is to estimate or interpolate y. Okay, the question asks you when, okay, x equals to 2, so what is y, right? So you just use this interpolated function equation where you have here y equal to 0.358. So just substitute when x equals to 2 here. Okay, so just substitute y equals to 0.358 multiply 2 minus 0.358. Okay, therefore y is equal to 0.358. Okay, this one is known as estimated value. Value that you obtain from the interpolated function or equation is known as estimated value. Okay, done with A. Okay, now we go to the B. Okay, let's erase this one. We go to B. Okay, same steps. Okay, just we change the value here. Okay, of x and fx. Okay, so step 1 is to identify points lah. So we have, okay, x1, y1. So is 1, 0, x2, y2. Okay, is 4, okay, and 1.386,294. Okay, and then step number 2, do the same thing, okay, to find slope, right? Slope. So it's given by m equals to change of y over change of x, which is, okay, 1.386,294 minus 0 over 4 minus 1. So you will get the answer is 0.462. Okay, then you need to find, okay, the slope lah. So it's given by y equals to mx plus c. We have m, which is 0.462. Okay, we take the point here, the above point, which is 1 and 0. You also can take this second point, yeah. We'll get the same answer. So 1, 0 is at 0 and x 1 lah, plus c. Therefore, c is equals to negative 0.462. So from this slope and this intercept, you can set up the equation, which is y equals to mx plus c. Just substitute what is m and what is c. So we have m equals to 0.462, okay, x minus 0.462. Okay, then step number 4, okay, to estimate lah, when, okay, x equal to 2. So y equals to 0.462 multiply 2 minus 0.462. Okay, therefore y equals to 0.462. Okay, here we have additional questions. For each of interpolation means that for A and B, compute the percentage, okay, relative error. So the error lah, relative error, based on the true value. This true value is the value for the actual function that is given, which is ln 2 here. So even if it is doesn't stated in the question the value of ln 2, this one is the value of ln 2, you also can just press the calculator. You will get the same value here. So later I will show you, okay, below how to solve to find the relative error for A and B. Okay, I find relative error, percentage of relative error for A first, okay. So it's given by actual value. Okay, actual value is a value that you obtain from the calculator minus estimated value over actual value. Okay, you have absolute, okay, because error cannot be negative. Multiply 100. So actual value is ln 2 minus estimated is the value that you obtain from the interpolated function, which is 0.358 over ln 2 multiply 100. So you will get 48.35%. So this for A. Okay, what about B? Okay, B, okay, percent of relative error. Okay, same formula. Okay, just substitute the value ln 2, and Y is for estimated value is given by this one. Okay, 0.462 here minus 0.462 over ln 2. Okay, multiply 100. So the answer here is 33.3%. Okay, so what you can conclude here, okay, as you notice here, okay, for A, x is from 1 to 6, and for B, x is from 1 to 4. Okay, A 1 to 6, okay, B 1 to 4. So what you can conclude here, okay, let's take a look here from the relative error. Okay, A, okay, the interval is from 1 6. This one is A. So the percentage of relative error is 48.35%, and B from 1 to 4. Okay, whereby the percentage error is, let's take a look here, okay, 33.33%. So what we can conclude here that using shorter interval, it will reduce the error. So very easy, right? For linear interpolation, okay, or first order, you just need to use the straight line equation. Okay. Okay, now we go to the quadratic interpolation or second order. Okay, second order polynomial using, okay, Newton divided difference. Okay, so this is basically the equations for quadratic interpolation using Newton divided difference. Okay, this one is for second order. Okay, let's take a look. Okay, the equation here that I star here. This one is the general equation for Newton divided difference in order to find the polynomial function. Okay, this one is the general. Let's say, okay, you have the cubic function, okay, f3. So it will be, okay, b0 plus b1 x minus x0, okay, plus b2 x minus x0 multiply x minus x1, okay, plus, because we have third order, right? So we have b3 x minus x0 multiply x minus x1 multiply x minus x2. Okay, very easy. Just follow the sequence here. Okay, and then you have here the unknowns b0, okay, b1 and b2. These are the unknowns that you need to solve in order to find the interpolated function. Okay, now we go to example 2. Fit a second order polynomial to 3 points. As I mentioned before, for the second order or quadratic polynomial, you need at least 3 points, right? So the question have asked you to use the polynomial to evaluate ln x. In other words, to find what is the fx when x equal to 2 here. Okay, when x equal to 2. So the first step, okay, is to construct table, also known as Newton divided difference table, okay, to find, okay, unknowns or BI. Okay, so for the linear, okay, no need to construct this table because it's very straightforward. Okay, you just find the slope and the intercept by using the straight line equation. But for the second order, okay, it's easy for you to use this table in order to find the unknowns that you have. So what you need to do for the first column here, Okay, just write back what is the value of x that you have, s0, s1 and s2. Okay, 1, 4, 6, and also the fx here. You have fs0, fs1 and fs2, the value. Okay, so since you have the second order, means that you have till second divided difference. Okay, so you have first divided difference and second divided difference for the second order polynomial. Okay, now we start with the first divided difference. For first divided difference, actually we want to find the slope lah. So the slope is the change of y, or the change in fx over change in x. Okay, over change in x. So always lower minus upper. So let's draw the arrow like this. Okay, just follow this arrow. Okay, always lower minus upper. So we have fx here. Okay, 1.38624 minus 0 over x is lower minus upper, 4 minus 1. Okay, so 4 minus 1. So you will get here 0.462098. This one is for first and second point. Okay, now we go to the second and third point. Okay, always lower minus upper, lower minus upper. So 1.791759, okay, minus 1.38624 over, okay, 6 minus 4. So the answer is, okay, 0.2027325. Okay, this one is for first divided difference. Okay, now we proceed to second divided difference. Okay, the value that you obtain here, okay, in the first divided difference will be your numerator in the second divided difference. Okay, whereby you minus lower minus upper. So let's write here. Okay, for second divided difference, okay, the row here. Okay, so 0.2027325 minus, okay, 0.462098. Okay, this one is for numerator. You just bring forward, okay, the value from the first divided difference to the second divided difference as its numerator. Okay, meanwhile for denominator it will be, okay, the change of x. So what is the value that you will take? Okay, the last value of x. Okay, if you follow this arrow, this one lah, 6, okay, minus, okay, the initial value of x, which is 1. Okay, so 6 minus 1, or you can see here 6, this is the last value of x, minus 1. So the answer here for second divided difference is negative 0.0518731. So what is the value of b? Okay, so you have to take note here. Okay, the first entry, okay, start from fx here, yeah, start from fx here. Okay, the first entry for each column is the value of b. Okay, of b. So we start with b naught. So what is the b naught? Start with the fx here, 0. This one is your b naught. Okay, so the first entry for each column, as you can see here, okay, from the formula, the b naught here, okay, the b naught is basically your fx naught. Okay, so start from fx lah. So this one is your b naught. What about b1? The first entry for each column, this one. Okay, this one is your b1. What about B2? Okay, the first entry for the second divided difference, this one, B2. So now, after you found what is B0, B1 and B2, okay, you can substitute, okay, X and B into, okay, equation, polynomial, second order equation. Okay, so you have, for the second order, the equation is f2x, okay, equals to b0 plus, okay, b1 x minus x0. So you just need to substitute what is s0 and b1 and b0, okay, plus, okay, b2 x minus x0, okay, multiply x minus x1. So we have b0 here 0 plus b1, which is 0.462098, multiply x minus x0, which is 1 here. This one is your x0, which is 1, okay, plus b2, which is negative 0.0518731, negative, right? So negative, okay, 0.0518731, x minus x0, x minus 1, okay, multiply x minus x1 is 4. So this is the interpolated function using polynomial, okay, Newton divided difference method. Okay, so later you can find what is the value of fx when, okay, x equals to 2. So you just substitute lah. So 0 you can cancel out, so you have 0.46298, okay, substitute here, x equal to 2, okay, so 2 minus 1 or 1 lah, minus 0.0518731, okay, 2 minus 1 multiply 2 minus 4, and the answer here is 0.565844. So the more value of decimal places that you take, the more accurate the value will be. So please take the most value that you can. Okay, so after that, okay, you have to calculate the relative error. Relative error given by, okay, actual value minus estimated value over actual value, okay, multiply hundreds. Okay, so we have ln 2 minus estimated value, this one, 0.565844, okay, over ln 2, okay, multiply 100, where you get 18.37%. Okay, this is how you find the second order polynomial using the Newton divided difference. Okay, now still on the Newton divided difference, but this time on the third order. So at least for the third order, we have at least 4 points lah. So let's identify this point. We have S0, S1, S2, and S3. And this one is Fs0, okay, Fs1, Fs2, and Fs3. So since we have third order, means that we have tilted divided difference. First divided difference, okay, second divided difference, and the third divided difference, right? So the first method is to construct this Newton divided difference table and to find the unknown. So just like the previous example, you need to write back the value of x in the first column here, negative 1, 0, 1, 2, and fx in the second column here. So the first divided difference is the slope, right? So slope always, okay, lower minus upper. So negative 4 minus, okay, 3 over, okay, 0 minus negative 1. So the answer is negative 7. Okay, this one is for first and second point. We go to the second and third point. Okay, 5 minus negative 4 over 1 minus 0. So the answer is 9. Okay, so done with the second and third. Now we go to the third and fourth. Okay, always lower minus upper, negative 6 minus 5. Okay, and then over 2 minus 1, which is, okay, negative 11. So whatever that you have in the first divided difference here, you need to bring forward to the second divided difference. So this is the error. Okay. Okay, the value that we obtain in the first divided difference will be your numerator. So start with this one, these two here, 9, okay, minus negative 7, and then over the change in x. Okay, so the last value of x, if you follow this error, it will be 1. Okay, 1 minus, okay, and the minus initial value of x, you follow this error. Okay, negative 1 minus negative 1. Or you can take a look here, because we take this two range, right? So we can look at the denominator, 1 and negative 1 here. So 1 and negative 1 for denominator. Okay, we will give you the same value. So it will be equal to, okay, 8, right? 8. So now we proceed to the second one here. Okay, always lower minus upper, which is negative 11, okay, minus 9, okay, over, what is the value of x? This one, okay, the last value of x, this one, 2, and the initial value of x, which is 0. Or you can take a look here, 2, 0, okay, 2 minus 0, which is equal to negative 10. And okay, the answer in the second divided difference will be the numerator in the third divided difference. Always lower minus upper, negative 10 minus 8 over, okay, the value of x, okay, the change in x is 2 minus negative 1. So 2 minus negative 1. So the answer here is negative 6. Okay, as I mentioned before, the first entry for each column start from the fx will be your b. So we start with here, fx naught is your b naught, and for the first divided difference here, the first entry will be your b1. Okay, and then for the second divided difference, the first entry will be your b2, and for the third divided difference, okay, will be b3. So now you need to substitute this value into the polynomial Newton divided difference formula. Once you obtain the value of p, the unknowns p, okay, you can just substitute into the formula lah. So step number 2, we have for the third order f3x will be b naught, okay, plus b1 x minus x naught, okay, and then plus b2 x minus x naught multiply x minus x1, okay, and then plus, okay, b3, and then x minus x naught, okay, and then x minus x1 multiply x minus x2. So we have here x naught, okay, this one, x1, x2, x3. So just substitute everything. You have b naught is negative 3, okay, 3, okay. So b1 is this one, negative 7, multiply x minus x naught minus negative 1 will be plus 1 lah, okay, plus b2 which is 8, okay. So x minus x naught multiply x minus negative 1 will be positive 1, okay, multiply x minus s1 which is 0, so will be x lah, okay, multiply x here. So, okay, what about B3? B3 is negative 6, so negative 6, okay, multiply s minus s naught, s plus 1. So, s minus s1, which is s minus 0, which is x, okay, and then s minus s2, s minus 1. So, this is the answer, okay, the interpolated function using Newton divided difference method. I think that's all. Is enough to show on how to solve the interpolated function, to find the interpolated function using Newton divided difference method.